Hello, Professor. This is my submission for assignment 6, string algorithms. So the objective is to find the longest continual substring of vowels and consonants, continual prefix of vowels and consonants, and continual suffix of vowels and consonants using one of the four methodologies. So we'll be using the brute force method here to find the longest continual values. Moving on to the code. We start with the code here. Uh, we have a set called vowels, which has all the vowels. Uh, our first function is a function to check if the character is a vowel or not. This returns the function checks the given character if is in the list of vowels, returns true if it is present. If not, it returns false. Uh, Our next main function is the long vowel string function. This is to identify the longest substring of vowels here. Um, we have two variables, longest and I, which are set to 0. And then we start with the start checking from the first letter. We have a check last variable, which I'll explain when we come to the end. So we start from the first letter to see if this is a vowel. If the first letter is a vowel, and then we initiate a variable called j, which iterates between the second character and the next character, that is, and end of the word. And we check starting from the second character if any of the character. We again check if the character is a vowel. If the character is a vowel, it just does not go to the if loop, just increments and then checks again. When it sees that it's not a vowel, when it sees that it's not a vowel, it evaluates the longest, which is the longest is earlier value, which is initially set to 0, and j minus I, which is the difference between the initial variable and the end variable. Um, and So this check last we set to false so that uh, we do because since we do the evaluation here and we don't have to redo it, and it breaks out of the loop. Um, so if it is the last character and it's still a vowel, it doesn't go through this if block. It directly checks if it's the last character and then reevaluates longest uh, based on the max of the current value and the earlier stored longest value. We increment I by 1 to account for the last character as well, and we return the longest. So this is the base function here. Based on the same logic, we write the other functions, or we derive from this. Uh, so for the longest consonant string, we use the same logic, except that here initially we check if it's not a vowel, and this inside block we check if it's a vowel to terminate the counting. Rest of the logic is same for the long consonant string. Uh, the next function is to see if check the longest prefix vowel. Here we run an iterator right through the range of length of the words, and so every time we increment, we see if it's a vowel. So for example, if the first letter is a vowel, uh, it goes through the for loop again and checks the second word. If the second loop is also a vowel, it goes to the third one, and until it encounters a non-vowel, it goes through the for loop. And once it encounters a non-vowel, it returns that value, the index of that value. So if the length of the is, comprises just of vowels, then it returns the length of the word. We use the same logic for the longest prefix consonant, just in place of if just checking if it's not a vowel, we check if this is a vowel here to return I. Uh, Next, when we check the suffixes for vowels and consonants, we use the same logic that is used for prefix. We use the same prefix methods actually, except that the input is fed in reverse order, which is word of using list using a reverse list. Uh, Moving on to the brute force method, uh, we declare a set of uh, variables which are basically sets, and we also declare the counts to be zero. Uh, so word list is a list containing all the words in the given document. So for every word, we evaluate each of the six methods that we described above, and store it in a variable count, and we compare this count with the count of each of the condition. For example, here we check if the count value determined for the longest vowel is greater than the initial substring vowel count, which is set to 0. If that's the case, then we set the substring to the count, which is the greater value, and then we add the word to the list of longer substring vowel. Uh, if the count is equal, also we do add the word to the list. Uh, this is the same logic we've used for all the six cases here. So just skip this section. And here, as a part of main function, we print each of the we print the length of the longest vowel substring, consonant substring, vowel prefix, consonant prefix, vowel suffix, consonant suffix, and also the list of all the words that match these conditions. Uh, in the main function, we just open the input file, and for each line in the file, we replace commas and dots with empty characters, and then split it so that the word list contains all the all the words separated in the input document, and then we call the brute force here. Let me rerun this. Here you see the output. The longest vowel substring, longest consonant substring, we have 4 entries here that match the specific condition, and the rest of the list. Thank you.